Hello students and friends, welcome to my YouTube channels. Today I am going to discuss the simple concept of the support reactions and also basic idea I will give for the support reactions. How to find the support reactions in a beam. So we know already so many types of beam will be there. Simply supported beam will be there, overhang beam will be there, continuous beam will be there, and types of load, point load will be there, uniformly distributing load is there, uniformly varying load is there. So first what we'll do, we'll discuss the simply supported beam with the point load, and others whatever beam will be there, either whatever load will be there, UDL, UVL, that will convert into point load, then we'll solve the problem. That will be the very easiest method. So just watch. First I will go this explain in the how to find the support reactions for the simply supported beam, and under on that point load will be there. Point load also known as concentrated load. That vertically they will act vertically downward. So now see, simple problems I taken. Find the support reactions of the given beam. Some load I taken 5 kilonewton, 8 kilonewton, 6 kilonewton. So that one beam is there. AB is a beam is there, and these three loads acting on the beam. So that all the load that A and B point, they will share. They will share this load. Suppose one beam is there and two support will be there. Support here and support here. So how much load will be give? Suppose this side more weight, middle more weight, or whatever various load will be there. So this A and B, that must support, they will support. That is known as support reaction. So they will balance, they will share. A and B point, they will share the both load. So how we'll find? Its application is the structural field, construction field, civil work, the application will be there. So okay, so how we'll solve this question? Before this we should know what is moment. Moment is nothing but force into perpendicular distance. Moment is nothing but force into perpendicular distance. That only concept will utilize here. So, and before this we have to see what type of beam this one. Statically determinate beam or statically indeterminate beam. So what is statically determinate beam? If number of equilibrium equations will be equal to the number of supports, is known as statically determinate beam. If number of equilibrium equation not equal to number of the supports, that will be the statically indeterminate beam. So that we will discuss later. But this beam having support reactions only one. See here, RA and RB. So two support reactions is there. And equilibrium equations, we have three equilibrium equations we have. What is? Summation of vertical forces equal to 0. That means total vertical forces equal to 0. Summation means total. That is total horizontal force equal to 0. And moment about any point equal to 0. This is known as equilibrium equation. So three equilibrium equations, two reaction force. That means this is reaction force is less than equilibrium force. If the support will go beyond the 3, then that is statically indeterminate beam. Then we cannot solve by this method. So now this is statically determinate beam, this one. So okay, now how we'll find? Out of three equilibrium equations, we'll apply here two equilibrium equations, sigma FB and sigma FH, because here no horizontal forces. Here no horizontal forces. If here inclined force will be there, then only inclined force will be there like this, then we can resolve this and this. So one horizontal force will come, one vertical force will, but here no inclined force. Like these questions I will take later. First we will discuss today very basic concept, then only we will discuss further that things. Okay. So now how to find the RA and RB? That is called support reaction. So you can say here AB is a beam and RA and RB be the reaction force, you can say, reaction forces. RA and RB the reaction forces. So how to solve? We will apply the two equilibrium equations. Summation of vertical forces equal to 0. That meaning is total upward force equal to nothing but total downward force. This will take. Actually, sign conventions will take the downward force positive, upward force negative. Then you write this equal to this. Will not go that method. That of both are same only. So I am writing directly here. No sign plus minus confusion. So total upward force equal to total downward force. You see here what is upward force? RA and RB, two upward force is there. So right here RA plus RB. Upward force, downward force, how many is there? 5 plus 8 plus 6. So how much it will come? 19. How much it is coming? 8 plus 19 kilonewton, correct. It is coming 19 kilonewton. Give the equation number 1. One equilibrium equations over. Sigma H will not consider because it already no horizontal force, it will become 0 only. We will take the moment about A. You take moment about B also, nothing wrong. But once we are standing this side, so we will take our side. So moment about A. So how we will find the moment? We will find the clockwise moment equal to anti-clockwise moment. Here also negative positive will not assume. So what we will find here? Total clockwise moment equal to total anti-clockwise moment will take. So now look here, moment how we will take. Point A is fixed. Point A is fixed because I am taking moment about A. Now forget about 8 kilonewton, 6 Newton RB force. Think about 5 kilonewton. This is the distance. This is the 3 meter distance force. So force into perpendicular distance. See how rotating? This point is fixed. Due to the 5 Newton, how this rotates? Clockwise. So we can write here 5 into 3 clockwise rotation. So these rotations will come like this. 5 into 3 clockwise rotations plus a point is fixed for 8 kilonewton. 8 kilonewton due to this is the distance. This will rotate. 8 kilonewton will rotate. How will rotate? 8 into total distance, how much? 6. 8 into 6. This also rotation is clockwise. This also rotation is clockwise plus 6. Again this point is fixed with respect to 6. How will rotate? Again this will rotate clockwise. So what will be there? 6 into total distance, how much? 336 plus 8. Now no clockwise rotation. Now A point is fixed. Due to B, this beam will rotate. This beam will rotate like this. The beam will rotate like this. So RB into total distance, how much? 336 plus 2 plus 8. This is called anti-clockwise direction. So this is also clockwise. This is also clockwise. This is also clockwise. This is anti-clockwise. So what I told? Total clockwise is equal to total anti-clockwise. I wrote total clockwise equal to total anti-clockwise. Now if we'll solve this, 15 plus 48 plus 48 equal to RB into 10. So total how much will come? 100. It will come 100. How much I calculated? 1111. So 111 divided by 10. This is called RB. So RB you will get 11.1. Substitute RB, this 1 kilonewton, because this given kilonewton, so you will write kilonewton. Now substitute RB in equation 1. If you substitute RB in equation 1, so what will get here? RA. RA is nothing but 19 minus 11.1 is equal to coming 7.9 kilonewton. 7.9 kilonewton. So now we got the answer. What is? Find the support reaction. This is the answer for this. This is the key problem. Whatever another problems will solve, I will now itself I will solve. So we'll convert all the given UDL, UVL in the point load, and this way we'll solve the other problems also. That's why I did this before. So here see, if this 7.9 plus 11.1 if we'll add, it will come 19 only. So 19 kilonewton load is applying at the beam, and RA and RB share respectively. They share RA they share the load 7.9 and RB share the 11.9. Now beam is balance. Beam is balance. Okay. So this. Now look here. Another questions. This is the key problem here. Now another questions how we'll solve. This questions what is given? One beam is there, 6 kilonewton point load and 12 kilonewton we have uniformly distributing load. What is load this one? UDL. UDL known as uniformly distributing load. This load also known as rectangular load. Rectangular load. Rectangular load. This is also known as rectangular load. This symbol will be like this will be there. This symbol will be like this, rectangular load. Okay. So rectangular load we are telling or this symbol, both symbols they can use. Okay. So now how to solve this? So before this what we'll do, we'll draw the load diagram. We'll convert this rectangular load into point load. So how we'll consider? Two concepts is there. If this is the rectangle, length L, breadth B. What is the center of gravity point for this rectangle? So already we know center of gravity points will be in the middle will be there. L by 2. L by 2 and this side will be the B by 2. So you will get the center of gravity point will get middle. What is center of gravity point? Entire that rectangle weight will act at a particular point. This is known as center of gravity point. So if this beam will convert into point load, how this load will act? Load will act in the middle. Suppose this load something given W kilonewton per meter. This is length L. So it will come W into L load. But where will act this will? In middle. L by 2, L by 2. So this load will act in the middle. Why load will act in the middle? Because this UDL load will act in the middle point. Middle point why? Because UDL is known as a rectangular section. Another concept what is? Suppose this UDL is there. If UDL is here the W kilonewton per meter weight is there. This is length L. If this weight will act in this beam, how this beam will deflect? This beam will deflect like this. Then where is the maximum deflection? In the middle. Where will the maximum deflection? On the middle. That means that UDL load, uniformly distributing load, it acts in the middle point. That is called center of gravity point. So both any one concept you can remember or you understand. Okay. Now I am going to solve this problem. So before solving this problem, I will convert into the load diagram. Okay, this concept I am going to rub it. This will convert into load diagram. So how will convert the load diagram? See here. We'll extend this. This extend just a dotted line. This I am going to extend like a dotted line. And this extend dotted line. Now we'll draw the one line. Another load diagrams we are going to draw. Another load diagrams I am going to draw. Look here. This point itself RA reaction force. This load will be here itself acting. How much load will be there here? 6 kilonewton. Now this UDL. What is this distance? 3 meter. What is this distance? 3 meter as you will write. What is this distance? 2 meter. This is the RB support reactions. RA and RB support reactions. Now if we will convert this load into point load, we will get this model problem and we will solve simple method. So now where will be the load will act? In middle. Why? Already explained. UDL load will act in the center of gravity point. Load will act at the center of gravity point. Or if you load apply, this will deflect. This will deflect like this. So maximum deflections will be in middle. So what is the load now? 12 into 4. So 48 kilonewton. So load unit is kilonewton, but here kilonewton per meter means each unit per unit length, this weight acting per unit length. Now we got the load. How much will go? We got the load 48 kilonewton. Where is acting? 2 meter. This distance is 2 meter. Now look here. You forget about this. What is there now? 2-point load is there. 2-point load is there. We can solve this question. See, take the sigma F equal to 0. Now you look here. What we'll do here? RA plus RB. That means total upward force equal to total downward force. How much? 6 plus 48. Total downward force over 1. See here. Total upward force equal to total downward force. We did. So how much will come? It will come to 54 kilonewton. Now moment about A. Total moment about A. So this will take clockwise is equal to anti-clockwise. Now 6. Don't see this diagram. Now 6. 6 into 3. What is that? 6 into 3. Clockwise rotation. This is 6 into 3. Clockwise rotation. Plus this load. 48. 48 into total distance how much? 3, 3, 6 plus 2, 8. This rotations also clockwise. Now any other load is there? Not there. Then anti-clockwise load. RB into total distance how much? 6 plus 4, 12. 12. Now if we'll solve, how much coming this? Already we have the calculation. 402. So RB equal to 402 divided by 12. This will multiply and it will add. It will come 402 into 12. So 33.5 kilonewton. 33.5 kilonewton. Now substitute this in equations. Give here 1. So what you will get here? RA equal to 54 minus 33.5. How much you will get? 20.5. 20.5 kilonewton. If you will add both, how much? 33.5. 33.5 plus 20.5 should come 54. That means total load how much? 6 plus 48, 54. A and B sharing this. A sharing 20.5, B sharing 33.5. This way we can solve the support reaction. So this today I take as very simple problem, simple concept, but whatever this completed, one more UDL will be there, UVL will be there, will convert into point load, and this is the method. Always will follow, and this way we can calculate this. Okay. So next video what we'll do, we'll take some complicated problem, two UDL, one UVL, and we'll convert into point load, and this method you have to follow. You watch this video, then only second video you will understand. Okay. Okay, friends, watch this video and give the feedback and like and subscribe these channels. Okay. Thank you.